Hi everyone. Okay, so in this session I'm going to continue our lecture on topic 3. So in the previous lecture I have discussed in detail on the method of joint. So I have mentioned that we have another method to learn on the thrust analysis, which is on the method of sections. So this method also can be used to solve internal forces in the member. Okay, so basically this method is very useful when you want to determine only some of the member forces in the truss. So if you compare this with the method of joints, so basically method of joints is you need to find out all the internal forces in the member. So where in this method of section you can jump into the member that you want to solve without determining the others or the rest of the internal force member. Okay, so meaning that you can skip the step or the process to the members that you are interested to determine. Okay, so let's look on the step. I mean the method or the simple guideline. Okay, the procedure of analysis for this particular method. So basically, it's involved three simple steps where the first step you need to consider the sections where it consists of maximum of 3 numbers of honest member. So actually you need to cut that member. You need to divide the thrust into 2 points, which is you need to draw the line, the intersection line to divide the thrust into 2 portions. Okay, so the line must be crossed over a maximum numbers of 3 members. Okay, so that's the rule for this particular method. Okay, so the second step, you need to taking a moment at a point where the 2 members intersect. So this we will see in details in the example, and the rest of forces can be solved by considering the summation of force in the vertical and horizontals equal to 0. Okay, let's see in detail how we can use this particular method to determine the internal forces in the truss. Okay, so this is the example that we're going to use in order to demonstrate the method of sections. So you can see that this truss consists of pin and the roller supported at A and E respectively. So this truss is loaded by the point loads 5 kN at joint D and C. So the problems that we want to solve here is to determine the forces for member BC, BD, and DE, which is this member BD, BC, and DE. So by looking on these procedures, so you need to draw one line that passes through these 3 members. Okay, so which is a member BC, BD, and DE. So you can see that I'm going to demonstrate here. So you need to draw this particular line here. Okay, so these lines has been across member ED, DB, and DC. Okay, so and based on this line, you can see that this truss has been divided by 2 portions, which is the upper part here. So this another portion, the lower part of this particular line. Okay, so we will look in detail on this in the next slide. Okay, so as usual, find out the reaction at supports. Basically, this particular step can be skipped if you consider the upper portions. Okay, so because if you consider the lower portion, you need to take into account of the particular reaction. So in other words, you need to calculate the reaction at support. Okay, okay, so this is the line that I has drawn in the previous slide. So you can see that this line has divided the thrust into 2 portions, so the upper portion and the lower portion. So you need to choose the upper portions, what you can see in detail here. So this is the upper portion, so this is a lower portion of line. Okay, so if you consider the lowest portion of lines, you need to calculate the reaction at support. But if you consider the upper portions, so basically you can skip to calculate the reaction at support. So and let's move on the next slide, how we can solve the internal forces in member. So in the solutions, the upper portion has been selected. So meaning that the reaction as support is not used to solve this particular problem. In other words, actually that particular step is not required to solve this problem. Okay, so so this is an internal process of the free body diagram for this upper portion. So you can see that the first assumption is by assuming that all the the unknown forces in tension. So all the arrow is outward from the joint. Okay, so you can see obviously here FBC is outward from the joint, FBD and DE as well. Okay, so and by looking on the step that you have seen in this slide, so you need to choose only one portion. So we have done it, and you need to choose a point where the two members intersect. So actually the joint that you need to choose here is a joint B. So where this member FBD and member FBC intersect at the joint B. Okay, so by taking a moment about point B, you can see that we can solve for the FDE. So which this member will be eliminated in this equation. So the FDE is equal to 5 kN. And you can proceed to another step by considering the summation of force in horizontal equal to 0. Okay, so you can see that we have negative DE to the left, and we have negative FBC cos 45 to the left as well. Okay, so and here you can solve for BC, since the DE has been calculated in the previous step here. So and the FBC here you can see that is equal to negative 7.071 kN. And the last step, you can solve for FBD value by considering the summation of force in the vertical. So you can see that the FBD is equal to negative 5 kN. Okay, so you can see that this method is very simple to solve the internal forces that we want to concentrate to, okay, without solving the entire force member. Okay, so that's it for these sessions. Basically to look further example problem solutions, you may refer to the our textbooks. Okay, so in there they have many problem solutions, variety of problem of solution and situation where you can see in detail. So that's it for this session. Thank you for listening.